So we have in this first session on InTaVia we have 6 presentations, and the first presentation is given by Matthias and Jouni. They will talk about how to build knowledge graphs for the age data. Please go ahead.
Yeah, hi everyone. So we are going to give you a short introduction into how the InTaVia Knowledge Graph is built and how it's working, and also how the ontology is created. So let's start with InTaVia as such. You might have heard of it. We will nonetheless repeat, maybe I'll do that like that, the goals and the project itself. So the InTaVia project is a H2020 project where 4 countries are involved: Slovenia, Austria, the Netherlands, and Finland. It started in 2020, and it's only 1 month to go. So we should be pretty final, even though there's still things missing. Some of the goals of the project were to integrate 4 national biographical dictionaries into one data source. So that's the Slovenian, Austrian, Finnish, and the Netherlands national biography. Then further enrich that data with linked open data and NLP, and provide an online platform on top of that knowledge graph using visual analytics to analyze the data. Some of the research questions we had, or the 3 main research questions we had, were: the first one was, is it possible to integrate those different prosopographical resources and create an almost homogeneous resource? Then, can we use NLP and linked open data to enrich the less rich data points in the graph? And does visual analytics provide useful means to analyze such a data set? The tech stack for the backend that we are presenting now is a fast API that provides the REST endpoints for retrieving the data, including Pydantic for type checking, so that we are providing type-safe data. Then BlazeGraph, which is a triplestore as the database backend, Ginger for creating SparkQL queries, and the Redis for caching the queries so that the queries are faster resolved. So this is kind of an overview of the whole data set. On the left side, you see the original sources, the digital national biographies, and then those biographies go into the knowledge graph. That's what we are presenting here. And after the knowledge graph, via the REST API, we have the visual analytics studio, the storytelling suite that are going to be presented later on. So for the backend side, or for the system itself, we see on the left side again the object databases and the prosopographical databases that are used, serialized using prefect workflows into the knowledge graph. So that's the 2 things that we are going to present today. And we first had a Garlic API endpoint, a system that Daria colleagues from the Netherlands originally developed, but we switched that for a custom component, as I said before, built on top of Fast API. And then consuming that is the data curation lab, the VS Studio, and all the visual components that are going to be presented in later presentations. So the knowledge graph itself. So currently it contains about 260,000 person proxies. So Jouni is going to talk about the data model a bit later. Person proxies are basically one view or one data set that we have on one person. Then 35,000 place proxies, 170,000 CHO proxies, so images, letters, cultural heritage objects. Yeah. So these are the 4 data sets per entity type, basically. On the top left, you see the Austrian data, which also contains institutions. The top right is the biography sample, the Finnish data. Bottom left is the Netherlands data, and bottom right, the Slovenian data. What you can see here is that the Austrian and the Finnish data are more rich regarding events, and the data from the Netherlands and Slovenia are less rich in that regard. Then we have here the entities across data sets. So which entities do we find in two data sets? So there is, of course, a bigger overlap between the Austrian and the Slovenian data. And there is, for example, no overlap at all between Slovenian and Finnish data. Then here is an events histogram. It is a bit difficult to read, actually. So the green one is the biographical events, like birth events, travel events, and stuff like that. And the blue stack is the CHO events. So what you can see here is that we have a lot of CHO events, so painting events, for example, for the 17th century, which is coming from the Dutch data set and from the Wikidata, where we queried all the CHO data from. Then there is obviously a big gender bias in the data set. So as you can see, the Austrian data set, for example, has only around 900 female biographed persons, where we have 17,000 males. There is on the top left, on the bottom left, you see the biography net data. There is actually was a data problem that has been solved already with the gender, but we haven't updated the images yet. And if we compare that gender bias over the centuries, of the birth centuries, you see that, at least in the Austrian data, there is a small rise towards the 20th century in the share of the female in the biographies. Then, if you look at the number of events per person, we have on the left side the number of events per person, including CHO objects. So you see that there are some of the people in, for example, biography net Austrian data, but also biography sample that have over 2,000 events attached to them. That's mainly people who have written the dictionary entries, for example, and all the dictionary entries are to be found in Wikidata. And on the right, you have the events per person without the CHO objects, and what you see there is that biography sample is the richest regarding the events, then it's the Austrian data and biography net. For Slovenian data, we currently have only birth and death events, basically, plus the CHO events that we found in Wikidata. Yes, and that's the whole knowledge graph on one image. So there is not much to see apart from that there are two clusters. The bottom right cluster, so the orange one, is the Austrian data. Top left is the biography sample data. You see that there are some connections in between, and all the floating points around biography net data, so the data from the Netherlands. That's because they haven't annotated the entities with reference resources, so we cannot attach those entities that they have in events to the rest of the graph. So how does the workflow, the data flow in our system? So we start off with the original data. So for the Slovenian biography, it's, for example, CIDOC. For the Finnish data, it's already CIDOC CRM, and for the Austrian data, it's a JSON API. We convert that with these prefect pipelines or on local machines to the target ontology, so the IDM-RDF ontology, and put that in source named graphs in the triplestore. Then, on top of that, we run further enrichment flows using linked open data mainly linked open data like Wikidata, and create a InTaVia harmonized named graph, which is basically pointing to the source named graphs. Jouni is going to speak on that just in a minute. And then we have SparkQL queries that query that knowledge graph, convert it to a JSON, and you return it via that fast API to the front end or to the user. Yes, so how is the InTaVia RDF processing actually working? So if you return data from an RDF endpoint, what you get is basically lines of data. So what you see at the top left is two labels for one person, and what the endpoint returns is actually two whole data sets. So it's duplicating the ID of the person, and it's in the second row, it's another label than in the first row. But what we want to get for the front end to be easily computable is a nested JSON. So what we have here is in the API a class definition that says our person class has a person attribute which is the ID basically, and it has a label attribute which can be a list of strings, so alternative labels for example. And the system that we have basically using this definition then constructs this nested version of the data set where it says then this one person has the one ID and it has these two labels. Yes, Jouni.
Okay, then next moving on to the IDM-RDF, which is the data model for InTaVia Knowledge Graph. So IDM here refers to InTaVia Data Model, and RDF is the technological base or the generic data model that's used for building linked datasets. So the data model is based on CIDOC CRM, which was already shown in the architecture diagram. So CIDOC CRM is a ISO standard for modeling cultural heritage data. It's a harmonizing data model and it's based on events. So we can think of a person's life as a chain of interlinked events which happen in place and time. We have extended this CIDOC CRM with our own bio-CRM extension for which we use for representing the roles of persons in these events. So for example, in a production event of a painting, a person can be in a role painter. So we can store this kind of semantically rich information. Then we use RDF named graphs for separating the different data sources. So we can have pieces of information regarding, let's say, the same person in several of these biographical data sets, but then we want to keep them as separated so we can kind of manage them and also keep track of the provenance, which piece of information is coming from which source. We also use IDM, which is Europeana Data Model, so we use that, or inspired of that, a data model for modeling the cultural heritage data objects. And we have, regarding this, we have made preliminary mapping of our data model to Europeana Data Model. We have also adopted from Europeana the so-called proxy model, which is also related to kind of separating the different views coming from different source data sets. And I will give you an example of this further on. Then work in progress, we plan to use PROV-O for modeling the provenance data and BibFrame for modeling the references and citations of biographies. So this is an example of a typical event construction used in InTaVia Knowledge Graph. So we can have an event like, for example, painting or producing a painting, and the event can have a person or any kind of entity, for example, person in a role of painter, for example. And there can be another person in a different role related to the same event, and we can have a time of the event and also the place of the event. So this kind of interlinks together the different actors and places and times in the knowledge graph. Then about the named graphs, here we can see an example of three different named graphs. So on the top of the view we have the Europeana data in its own graph, and then on the bottom we have data coming from Finnish biography sample, and in between, in the middle, we have the kind of InTaVia shared entity graph that integrates these different source data sets. So for example, we can have from Europeana this painting of Finnish painter Albert Edelfelt, and then in the bottom we have the biography of Albert Edelfelt from the Finnish biography, national biography, and then in the middle we create shared identifiers or entity representations for the Albert Edelfelt and also the painting, and this way we can interlink these different pieces of information coming from different data sources. Then how is this entity linking done in practice? So we have different kinds of enrichment workflows, and this is an example of the basic interlinking flow that we use. So for example, in biography sample graph, we have a person, Giuseppe Acerbi, an Italian natural historian and explorer and composer. So we have his biography. On the other hand, we also have in the Austrian biography dataset, we have also his biography. So how can we know that these are the same person and interlink them? Well, luckily in the Finnish dataset, we have external identifier. So we have the Wikidata ID of the person Giuseppe Acerbi. And similarly for the Austrian dataset, we have the GND identifier, which is the authority file of the German National Library. So then we can actually use Wikidata database to query for more information. And actually in Wikidata there is this very relevant piece of information that this Wikidata entity's GNT identifier is actually the same identifier as the one that's used in the Austrian biographic sample, not biography sample, biography dataset. And by using this information, we can actually deduce that these person proxies in these two different biography datasets are actually the same, and based on that we can create the kind of integrated person entity for this Giuseppe Acerbi, and we can say that these person proxies are connected to the same real-world person. And then moving on to the IDM JSON.
So, and as I said before, we are delivering JSON for the API and also for consumers and not RDF. And the idea of JSON was that why we wanted to provide JSON was that front-end applications easily deal with JSON APIs where it's difficult to use RDF or SparkQL endpoints, and we would also want to have a simplified version of that complex data model that you saw just before. And so the simplified version basically attaches some of those events that Jouni showed, like the gender, for example, to attributes of the node, and creates then a linear node history using the other events that basically remain. And this looks then like that. So we have objects, all object types, so persons, CHO objects, places, groups have a node history, which basically is a list of events with time frames and entities attached. So let's look at that in the actual running system, if it's running. Yes, so that's what you get from the API directly. And I'm going to try now to query for the Acerbi that Jouni just mentioned here. So here is the entities endpoint. There is an simple entity search endpoint. There is several filters, but basically there is one query. There's one query parameter that you can use. So if we query here for Acerbi, so execute, we get here a list of basically two. So there are two Acerbis, but the second one is the one that we are searching for. So you see here the ID basically, and here these linked IDs. So one of the linked IDs is the biography sample entry, the other one is the ABIS entry, and then we have here the gender, as said before, occupations coming from both of the dictionary, and then alternative labels, and here is then this relations list. So it's basically not readable because it's base 64 encoded, but it's a list of events that this person had that you can then retrieve from another endpoint. And if you look at that in the front end, this Acerbi looks then like this. So you see here the links to the different instances that we have, the Wikidata, but also the gemeinsame Normdatei from the German National Library and the Austrian APIS entry. And you have then here the occupations as in the API, but also this timeline of events that we extracted from the sources. And what you can see, for example, here is that we have two different birth events, because in the Finnish dictionary, the birth event is only given with a year, and in the Austrian dictionary, there's the exact date. So that's why we have two birth events. And on the right side, you see this very small Austrian biography that's in the Austrian portal also written. Yes. So there are still things that we're still working on, although I said we are nearly to the end of the project. So we want to have data validation via Schlögl, because one of the big problems is that the data is not in exactly the same format, although we have this IDM-RDF ontology. We are still working on the ingestion workflow. There are still some prefect pipelines that we want to do. Some of the challenges that we were facing during the project are accuracy versus feasibility. As Jouni showed, we ended up with a quite complex data model that is actually everything else but easy to use in the practice. And it's even more complicated if you include all the provenance data of when was which data point created with which system and stuff like that. Then the different languages. So as you also saw, the occupations, for example, are in Finnish, English, and German in this RGRB case. So we would need to do some automatic translation for that. Then there is a lot of duplicates in the data. And there's also a problem with the performance of the API, because triple stores are not exactly performant databases. Yes, that's about it. So you see here the GitHub organization in InTaVia, where all the repositories containing all the data and also this presentation are to be found. And the second link is the backend, the REST API backend, and the third one is the front end that you can already play around with if you're interested.